Greetings, ladies and gentlemen. Welcome to Gnostic Academy. In this video, we are going to solve physics or science paper 1 of 2024 GCE. Okay, we're going to consider section B. Okay, let's consider section B. Then after section B, we'll go to section C. All right. So let's begin. Answer all the questions in this section. Write your answers in the spaces provided in the question paper. B1, the first question here, figure B1.1 shows an instrument used to measure a physical quantity. All right, a physical quantity. So this instrument here, the name of this instrument is a micrometer screw gauge. Okay, the quantity that it measures is length. Okay, it measures the length. Now, let's read the question. Let's read the first question. A, what is the reading shown on the device? What is the reading shown on the device? Okay, so the way you read the micrometer screw gauge is that you need to know the main scale. Okay, main scale reading. Okay, main scale reading plus the secular scale, this one. Okay, plus the secular scale. Now the secular scale reading, let me just say CSR reading, before you add it to this one here, you multiply it by 0.01. okay, so what is the main scale here according to this question? So this is 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5. okay, so down here it is the half, so 5, 5.5, 6.6, 6.5, then this is 7, 7.5, 8, 8.5, so this is 8.5. So the main scale is 8.5. okay, 8.5 millimeters. Okay, then the secular scale, since this is 20 and this is 25, so this is 20, 21, 22, 23, 24, 25. So this is 20, 21, 22, up to the it has to be in line with the horizontal line in the main scale here. Okay, so this is 21, 22. Now listen, so the secular scale will be 22 multiplied by 0.01. okay, 0.01. all right, now when you do calculations here, it will be 8.5 plus, when you multiply 22 by 2, we're going to have 22 times 0.01, we're going to have 0.22. okay, 0.22. so 0.22 plus 8.5. all right, so the reading is 8.72. okay, 8.7 what? 8.72 millimeters. all right, next question. The next question is name part P. all right, look at part P. So part P here, this is the spindle. okay, it is the spindle. Then this one is an anvil. Then E is a ratchet. Okay, ratchet. Let's go to the next question. What is the function of the part labeled E? Okay, what is the function of what? Of the ratchet? Okay, so the function of this spindle is that it, you can say it prevents the person or a person who is using the same ratchet, I mean the same micrometer screw gauge, from exerting or applying too much pressure. Okay, too much what? Too much pressure. Let's go to the next question, which is the last question on question 1, B1, which is give one precaution you take before using the instrument. Okay, before using the instrument. So there are a lot. You have two, you can say. Okay, so clean the anvil and the spindle, all right, so that you can get correct measurement. You can also say, since was told us give one precaution you would take before, not after or while it's during you, while it's using, say before. You can say zero the instrument. Why are we zeroing in the instrument? To avoid the zero error, okay, to prevent errors. Let's go to the next question, which is question B2. Question B2 is on simple machines. Figure 2.1, B2.1 shows a wheel and an axle for a simple machine used to lift a load of 240 newtons when an effort of 60 newtons is applied. Okay, so this is the diagram. The first question is define a simple machine. So you can say a simple machine, is a device that makes work easy or easier. Okay, or you can say is any device by means of which a force is applied, or by means by which a force is applied at a one point can be used to overcome a force at a different point. That is also a simple machine. All right. Now, always the load must be greater than the effort. If the effort is greater than the load, then that is not a simple machine. It is not making work easier. Okay. If you apply more force than the load, then the more effort than the load, then that is not a simple machine. All right. Next question. Calculate the mechanical advantage of the wheel. Mechanical advantage of the wheel. So mechanical advantage is equals to load over effort. Okay. Now our load here is 240 newtons. Effort is 60 newtons. So the Newton will cancel the 0 and 0. 6 into 24 is 4. So the answer here is just 4 with no units. Mechanical advantage and velocity ratio have no units, because they're just ratios. Okay. Second question: if the radii of the wheel R and the axle are 80, 16 respectively, determine the velocity ratio of the wheel and the axle. This is also easy. So here is we're going to say the radius of the wheel over the radius of the axle. So we're going to say capital R divided by small letter r. Okay, which is capital R is what? 80 centimeters. Then small letter r is 16 centimeters. The centimeters will cancel. Then 16 into 80 is giving me 5. Okay, 5. Then you go to the last question of question B, question 2. What is the efficiency of the wheel and the axle? Okay, so efficiency is the mechanical advantage over the velocity velocity ratio times 100 100% times 100%. So now when you substitute here, mechanical advantage is 4, velocity ratio is what? 5. Okay, then multiplied by what? 100. 5 into 5 1, 5 into 100 is 20, 4 times 20 is 80. So here is just 80%. Okay, 80% as the efficiency of this machine. All right, that's the solution. Let's go to the next question, which is question B3. Okay, B3. Okay, B3. A glass-sided box containing a mixture of smoke and air is illuminated, and a microscope is used to view the motion of the smoke particles. The first question, A1, define diffusion. Okay, define diffusion. So you can say diffusion is the movement of particles from the region of higher concentration to the region of lower concentration. Okay, down the concentration gradient. Down the concentration what? Gradient. Now, the other question is, state two factors that increase the rate of diffusion. So you can have temperature. You can say temperature. You can also say surface area. Okay, you can say surface area. Okay, A lot, even concentration is there. Since we are told to just write 2, let's just stick to 2. State 2 differences between boiling and what? And evaporation. Okay? 2 differences between boiling and evaporation. Now, you should know that boiling occurs at a boiling point, at a particular temperature, okay? Whereas evaporation occurs at any temperature. Okay? The other one, is that you can say during boiling, bubbles or effervescence or bubbles are observed, whereas evaporation can take place without bubbles. Okay? Then boiling takes place, you can also say takes place throughout the liquid, but evaporation takes place or occurs at the meniscus, the top of the liquid. Let's go to question 4. Question 4 is under waves, and the question reads, define the wavelength. Okay, define the wavelength. So you can say wavelength is the distance, or is the minimum distance at which a wave repeats itself. Look at this. So this is half. So this is where it is repeating, this wave is repeating itself. So this is the wavelength from here up to here. This is 1, okay? 1 wavelength. So this distance from here up to here is 1. From here, from the top here, from the crest up to the other crest, that is the wavelength. Another question, I think it's on the same. So they're saying, state the wavelength in figure of the wave in figure B 4.1 here. So this is the highest point. The wavelength, this is the wavelength. Okay? Wavelength, the symbol is lambda. Okay, like this. This is the crest. The highest point of the wave. The lowest point of the wave is known as the trough. Okay, like this. and this is the crest, like this crest trough here. Now we are asked to simply calculate, okay, state the wavelength of the wave in figure 4.1. Okay, now according to this, sorry, from here up to here is one wave. Okay, I mean it's half, not one wave. I'm sorry. This I mean this. It is one wave from here up to here, but what I'm trying to say is this. They form a shape like this. From here, this half and this half, 10 to up to this point. This is half of, this is 12.5, which is just 2.5. Even here, it is 2.5. Okay, so 2.5 plus 2.5, it forms this shape. Okay, half of a wave, which is 5. Okay, 10 to what is this? 5 to 10, it is 5. All right. So what you can just simply say, you can subtract 12.5 here minus, what is this? 2.5. We're going to get 10. Okay. We're going to get what? We're going to get 10. All right. It's as simple as that. Now we can say, since look at this, you can even say this. From here up to here, it is 10. This is a complete wave, just without even subtracting, calculating. This is from 0, 5, 10. This is a complete wave, you can see. So this is 10 centimeters. So you can just write here, 10 what? 10 centimeters. Okay, without even wasting much of the time. You can say 10 centimeters. And the next question is, what is the amplitude of the wave? What is the amplitude of the wave in figure what? In figure 4.1. Look at this. The amplitude, this is the distance, the displacement, okay? The displacement from this resting position, this line here. So this is 10. This is also 10. Now we get the positive value. So we're going to say 10, the unit is in centimeters. So even here, we're going to say 10 what? 10 centimeters. All right. The second question D, if the waves travel along the string at 0.5 meters per second, calculate the period of the wavelength of the waves in figure B4.1. 3 marks. This is simple. Now, look at this. We are asked to calculate what? The period. So, we can say the symbol for period is capital letter T is equals to time taken over total number of waves here. Okay, then, okay, so check this. Look at this formula. Period is equals to time taken over number of waves. But there is another formula we can use, which is period is equals to 1 over frequency. Okay, 1 over frequency. Now, which one are we going to use? Check this out. We are given speed here, so we can use this formula. Speed is equals to frequency times what? Wavelength. Let's calculate it. Since we know wavelength and speed, we can calculate what? Frequency. Now, wavelength, not wavelength, I mean velocity, you are given here is 0.5 meters per what? Per second, is equals to frequency, we don't know, but then the wavelength is 10. Now, since this one is in meters, we need to change this 10 to meters. by simply dividing this by what? 100. Okay, we divide it by 100. So in other words, here you have 10 over 100. Okay, of which this 0 and this 0 can cancel. You have 1 over what? 1 over 10. Now let's make it simple. This idea of 0.5, let's just get 0.5. And so 0.5 is equals to frequency times 1 is frequency over what? 10. Cross multiply. Frequency is equals to 0.5 times 10 is just half of 10, which is just 5. 5 what? Hence. Okay, these are the units for the units for frequency. Now that we've found frequency, we can use this formula to find period. Okay, 1 over frequency, which is what? 5. All right, 5 hence. Now, when you divide here, what are you going to? Okay, so 1 into 5 is 0. 1 over 1 into 10 is 2. So 0.2 seconds. So here you can just write 0.2 seconds. That is the period. All right. Thank you so much. So remember, the formula to use here entirely depends on the data that we are given. Okay. Let's proceed. Let's go to the question 5. Okay, so question B5, the first question is saying, what type of energy is in an infrared wave? Okay, so the type of energy here in the infrared wave, it is called heat energy. Okay, heat energy. Then the second question is saying, give the range of frequencies audible to the human ear. The frequency audible to the human ear is 20 Hz, okay, 20 Hz to 20,000 Hz. Okay, this 20,000 Hz can also be written as 20 kilohertz. Okay, so the question C is saying, define an echo. Now, an echo is the bouncing back of sound. So, an echo is the bouncing back of sound or reflected sound. All right. Then question D is saying, a plane sends an ultrasonic sound down the ground and receives the echo after 4.8 seconds. How high is the plane above the ground? Take velocity of the sound in air as 340 meters per second. Okay. So what we're going to do here, since it's an echo here, is an echo, the bouncing back of sound. So the formula that we're going to use is speed is equals to distance covered, now going to and fro. Okay, to and fro. So it is twice. So distance over time what? Time taken. Now we are given speed, we are given here. So let's substitute what we are given. Speed we are given as what is that one? Speed we are given as 340. 340 is equals to 2 times d for distance. Then time taken is what? Time taken is So the time taken is 4.8 seconds. When you cross multiply here, you're going to say over 1. So we're going to say 2D is equals to 340 multiplied by 4.8. So divided by 2, then these 2 and these 2 cancel. Therefore, distance is equals to, let me punch these on the calculator. Okay, so when you use a calculator, 340 times 4.8, okay, divided by 2 is giving me 816 watt. So this is distance, so it is 816 meters. Okay, so that is the answer, 816 meters. All right, let's proceed. The last question on question 5 is saying, give one way in which sound pollution can be minimized. Sound pollution can be what? Can be minimized. Okay, so one ways of minimizing sound pollution, you can say using a soundproof. Okay, so in rooms, okay, or in houses or buildings, okay, then you have others. So let's go to the next question. Now the question is saying, figure 6.1 shows a lens used to form an image drawn to scale. Okay, identify the type of lens in figure 6.1. So look at the object, and then here the image, these rays of light, they cross here, they meet, they converge. So the type of lens here is a converging lens. Converging what? Lens. Okay, the next question is, mention 2 characteristics of the image image formed. Number 1, so the object is smaller than the image, so you can say it is magnified. It is magnified. Secondly, it is, again, the image is real. Okay, is real. Now the last question is saying, what device uses this type of lens? Oh, by the way, this is also called the convex lens. Okay, convex what? Lens. What device uses this type of what? Of a lens to produce a similar type of image? Okay, so here there are a lot of devices that use this type of lens, convex lens. Okay, so you can use the projector, which projects the image on the projector screen. So that's all to question 6. Question 7 is, this is under electricity, or yes, electrical circuit. So the question reads, the question B7, not question 17. Figure B7.1 shows resistors connected to a 4 volts power supply. Okay, so this is the series circuit. Now, what type of series circuit is this? Is it a parallel or series, or maybe joint? This is a joint circuit. Okay, So what is the effective resistance of the circuit? So check this one. So they're asking us to find the effective resistance. So the effective resistance is the same as total resistance. So to find the total resistance, we are going to use, so total resistance is going to say, first we need to make, since this is a combination of series and parallel circuit, you have to make the parallel circuit into series circuit. Okay, so we're going to say 3 resistor 1, let's call this one resistor 1, resistor 2, and then this one resistor 3. So we're going to say resistor 1 plus, now in parallel circuit, if you have 2 resistors, what you do is, so we're going to say resistor 2 multiplied by resistor 3 divided by resistor 2 plus resistor 3. Okay, now when you substitute here, we're going to have resistor 1 as 3 ohms plus resistor 2 6 times resistor 3 6 times 12 over 6 plus what? Plus 12. Okay, so when you multiply here, you're going to have 3 plus 6 times 12. Okay, 6 times 12 is 72. All right, 72 divided by 18. 72 divided by 18, it is 4. So 18 here, it is 4. So in other words, here you have 3 plus what? Plus 4, which is giving us 3 plus 4, it is 7 ohms. Okay, 7 ohms. And 7 ohms is the answer. So we're asked to calculate the potential difference, the PD, across the 3 ohms resistor. So what you need to know here is that potential difference, which is the voltage, is equals to current times the resistor. So this is the resistor that we labeled as resistor 1. So we're going to say this resistor 1 here. Now, do we know the current? No, we don't know. So the first thing, we have to find the current. Now you should know that since we've made this circuit as a series circuit, we found a series circuit, we have 3 ohms, and what was the answer here? 4. Okay, when you add these, when you calculate the parallel circuit, we're going to have 4 ohms. 4 ohms plus 3, we have total resistance as what? 7 ohms. Now we are going to say current is equals to voltage over resistance, which is the total resistance. Okay, the voltage given here, as you can see here, it is 4 volts. The total resistance is what? 7 ohms. All right, so when you divide 4 into, so let me say it's what, 4 divided by 7 is giving me 0.57 to do 2 decimal places, 0.57 amps. Okay, therefore, to find the potential difference here, we're going to say current, which is 0.57 amps multiplied by resistor 3. Okay, multiplied by 3. So 0.75, is it 5 and 5 or 57? 0.57 multiplied by 4 is 3 multiplied by 3. Okay, the answer is giving me is 1.71. Okay, since it's potential difference, so it will be in volts. So 1.71 volts. So question 8, the question reads, figure B 8.1 shows a cathode ray oscilloscope CRO. This is the diagram. Name the process by which cathode rays are produced. So, cathode rays are produced by thermionic emission. All right, thermionic what? Thermionic emission. Then the next question is state the function of Y plates. Okay, state the function of the Y plates in the Sierra or cathode ray oscilloscope. The Y ray. Look at the Y rays. Okay, or the Y plates. Sorry. So the function is to deflect the rays up and what? Up and down. This is sideways, but the Y plate it is up and what? Up and down. Okay, so is to deflect the cathode rays up and down. Okay, so let's go to the next question. Why is the potential difference between the cathode ray and the anode very high? So this is very simple. So to increase or you can say to accelerate the electrons. Okay, electrons which are the cathode rays. All right, this is question 8. Also on question 8. Then question 9 B9. Question 9 is saying define nuclear fission. Not nuclear fusion, but nuclear what? Fission. So nuclear fission is the splitting of radioactive nuclei. Okay, nuclei. As this is done here, a lot of energy is produced. Heat energy is what? Produced. The next question, which is B2, is what is background radiation? What is background radiation? So this is the amount you can say this is the amount of radiation, okay, which is available on Earth, okay, every time or at all time. All right, now the question C is saying state 2 uses of nuclear energy. This is simple. Okay, so uses of nuclear energy, you can say it is used to make nuclear weapons. Another one you can say it is used for power generation. Okay, for power generation. Last question here is saying complete the following nuclei equation, where you have sodium and sodium here You have magnesium, you have the beta particle, and the gamma or Y ray. Or so this one we have sodium, which has 24 mass number as 24. Okay, then magnesium. Magnesium has also 24. Then down here it is 12. Then you have the beta and the alpha. I mean the Y ray or the gamma ray. Okay, now let's check what is next. Oh, we are done with section B. Okay, we're done with section B. So what I'm going to do is I'll create a separate video for section C. Section C, there are three questions. And you are supposed to answer 2 questions. But in the video, I will show you how to answer all the 3 questions. So the first one here, this is the second one under waves. This is under travel graphs or kinematics. And this one is under radioactive. Okay. So thank you so much. Remember to subscribe and like the video.